All right, this video is covering the derivation of the sum of a geometric series. This is great if you don't have a computer or software that will calculate the sum for your geometric series so that you can geometrically buy stocks. Okay, so let's say this sum is going to be your buying power, how much money you have available to buy stocks. So let's say it's $1,000. So you put $1,000 in for sigma. This is the symbol for summation, for summing up anything. So this is your $1,000 you put in. This R is your common ratio, what you're multiplying each buying point by. So let's say you start with $2, you buy stock with $2. The next buying opportunity will be $4, and R states that R equals 2 in that case, right? Because you're multiplying your buying opportunities, your buying points, by 2. So 2, 4, 8, 16, 32, right? So this is what we have here. So just imagine $1,000 and you start with $1, right? You put $1 in some stock, right? And then the stock dips down a little. So you want to double it. So you put in $2. It dips down even more. You put in $4 now. Dips down even more. You put in 8. Dips down even more. 16. And you want to know, well, how many buying points can I have? How many times can I buy a stock when it goes down and buy consecutively when it goes down? How many times if I have $1,000? Depending on your sum, how many buying points can I afford? So you see here, it's 1 to 2 to 4 to 8 to 16, 32, 64, 128. So it's doubling, right? So you multiply this by 2, right? So if we do that, we get 2 sigma. This is to the summation. And then if we times this by 2, right, we get 2 at first, then 4, because 2 times 2 is 4. 2 times 4 is 8, so on and so forth, right? And you get all these numbers. Now, if we find the difference between 2 sigma and sigma, well, we will get sigma, and we will get the summation for this series. So let's check it out. We're subtracting, right? So we can eliminate these 2's, right? We can eliminate these 4's, eliminate these 8's, 16's, 32's, 64's, 128's. And what we have left for 2 sigma is 256. So we put that in front, right? Because 2 sigma minus sigma. And then in sigma alone, we have 1. So 256 goes here, substitutes for the 2 sigma, and the 1 substitutes for the sigma. We get 256 minus 1, so the summation is 255, right? So that's how much money you can have if you want to buy stocks like this. Buy a stock with $1 and then $2 when it descends, $4 when it goes down even more, $8, 16, 32, 64, 128. Okay, so now let's imagine that this 2 is R. So we just denote this 2 as R. And, this could be, you can, multiply this by 3. So let's say you want to triple your money for the buying points. Like you want to start with $1, next time it's $3, and then next time it's $9, because it's more money, and it means you have more money in the stock, and therefore if the stock goes up, you will make more money, but with the same return on investment, but you'll have more money, right? So if you invest $100 in a stock, it goes up 10%, you make $10. But if you put in $1,000, it goes up 10%, you make $100. Okay, so here we have sigma, right, equals A. This is the first number, which is 1, plus A times R. R is 2, so this is like 1 times 2. Okay, so we get 2, right? So 1 times 2, we get 2. 1 times 2 times 2. R square, r to the power of 2, is stating that you are multiplying r 2 times by a. So 1 times 2 is 2 times 2 again, because we're multiplying again by the common ratio, r, and then we get 4. So on and so forth. So the next number would be a times r to the power of 3, and then the next number would be a times r to the power of 4. Now this last number is a times r to the power of n minus 1. Why is it that this is n minus 1? Well, because we start with the common ratio at the second number in the sequence, right? If it was in the first number, then it would just be r to the n. Okay, so let's say in this sequence we have 4 numbers. We have a, okay, which is just 1. So, and then the common ratio will be 2. So we have 1, 2, 4, and 8. So we have 1, 2, 3, 4 numbers, right, in the sequence. And how many times do we use r, the common ratio r? Well, we can just highlight it here. We have 1 r, we use r again, 2 r's, and then we're going to use r again. So we have 3 r's in the sequence, and the sequence has 4 numbers. So if we have 4 numbers and we use it 3 times, what we want to do is, if n is equal to 4 here, we do 4 minus 1, n minus 1, to get the number of times we use r. So it will be 3, right? Because we used it 3 times. 1 r, we have 2 r's here. 1, 2, 3 r's all together. So we have 4 numbers. 4 minus 1 is 3. Now, like we did similarly up here, we multiplied 2, the common ratio, for the sigma. We do the same here. R times sigma. You see the comparison? So r times sigma is a times r for this, the first space for n equals 1 in the sequence, right? R times sigma, so we have a times r square. R times r is r square. R times r times r is r to the third. Okay, so here we have, it just goes on, r to the 4th, r to the 5th, so on and so forth. Now we have a times r to the n minus 1, because this is going to a times r to the n, right? So it's r to the n because we used r for the first number in the sequence. Because let's say 1, 2, 3, 4, 5. This sequence has 5 numbers. How many r's can you see in the sequence? 1, there's a second r, third r, fourth r, fifth r. So 5 r's. So if you go to the power of n, 1, 2, 3, 4, 5, at this number, n equals 5, well, you just put in 5, and that's how many r's you use for the 5th number in the sequence. Now let's find the difference between r sigma and sigma. Like here, you can compare. It's the same thing, but we're just substituting this 2 in for the common ratio denoted as r. So if we do that, let's eliminate like terms. So a times r we eliminate this. This number is in between here, so we would just eliminate this, right? We eliminate these, okay? And then we are left with a times r to the nth power. And a, we can't eliminate a, right? Because a is not in r times sigma. So we are left with this number, this this series of variables and this variable, the initial value. So we can just do this, eliminate that, and eliminate all this. Now, look, it's r sigma minus sigma. So we put a times r to the nth power in front, and then a following this series of variables. Okay, so now we can factor out sigma in r times sigma minus sigma. So sigma times r, right, times -1. We're just factoring it out. Equals, we can also factor out a in this case. So if we factor out a, we get a times r to the power of n times -1. And therefore, sigma equals a times r to the power of n minus 1 divided by r minus 1, because we bring this r minus 1 over to the other side, and we get sigma. So now let's say you have $1,000, right? And your initial value, you don't know what your initial value will be. So A is equivalent to saying the initial value, but your R, you want R to be 2, right? To the power of n. Well, let's say we do know. Let's say $8 is going to be the initial value that we put into a stock. So we'll buy Microsoft with $8 at first. And then n is how many buy-in points, right? N equals the buy-in points. So it's buy-in points. Right? So it's like we can buy Microsoft 8 times if we buy it initially at $8 and we are doubling our money. So the first time's $8, second time is $16.32. So you can easily calculate by this formula, which is just the geometric series. Yep, this would be 2 in this case if we want to double. So this would just be 1. Okay, and then we just leave it like that. And you plug this in, you solve for n, you isolate n, then you get your buy-in points. And it's that easy.